Thank you very much. Thank you for coming, and thank you for being a part of this community. It's extremely intimidating sometimes to build this sort of project because there's so much that people want to do, and if everything is hard that you guys want to do, I am constantly amazed by the ambition and the futurism that this community represents, and it's humbling, and it's really, really helpful to see how this community just blows through all the obstacles in its path on the way to getting things live and working and then moving on to the next big thing as well. And really, if there's something futuristic and hard, it seems, whether it's quantum computers or advanced cryptography or eCache or whatever it is, Internet of Things, you guys want to do it, which is outstanding and is what makes this sort of thing fun. Now, I've got two things I want to talk to you about today. I'm going to talk to you about things that we're not doing, and then I'm going to talk to you about things that we are actually doing. Now, you might wonder, what's the point of talking to you about things that we aren't actually going to do, or we're not currently planning on working on? And there are a couple of reasons. One is that, although we don't have the resources to do everything because the Korda vision is so vast and the number of ways everyone wants to use it is so vast, we can still chip in with ideas to the community. And we can say, well, have you thought about this? Have you thought about that? So people in the open source community can go ahead and build things without us, while still having some confidence that if they want to make changes to the platform, if you want to extend the platform in some way, when you come back and send code reviews to us, it will work, and we will be willing to accept that into the design. And another one is that planning ahead helps us avoid painting ourselves, and by extension, all of us, into a corner. Because when you're building a platform, especially one with backwards compatibility, of course, it's very easy to accidentally ship something you then can't change later. And a part of this is avoiding problems, because when building platforms, every move is your last move, in a way. So I want to just throw out some ideas here for things we found interesting, and then at the end I'm going to talk about some of the new things we're doing. And I hope at least one of the three things I'm going to discuss will be interesting and inspiring to you. So I want to start with eCache. There's a lot of interest in retail eCache projects, typically from governments and often central banks. They want to phase out paper money, or at least they want to have a plan to do so, and replace it totally with electronic cash. Now, obviously, these projects are kind of inherently cool because there's something that you or I might actually use in our daily life, whereas, of course, most Korda apps aren't. So that's kind of interesting, but it would also, enable lots of things. Korda apps could sell things on the ledger to consumers, could integrate with websites and mobile apps and all kinds of cool stuff. Just, for me personally, it would also be kind of cool because this would, I started by writing this app. You see on the screen, this my first blockchain app ever. It was a Bitcoin wallet. In fact, it was the first ever peer-to-peer cryptocurrency wallet. So these projects are also just kind of fun for me because it's bringing it all back around in a giant circle. Nonetheless, I often find myself counseling caution about some of these projects, because very often they come with requirements that are extremely difficult or appear superficially at least to be contradictory. So for example, a typical request that we get is that the resulting tokens, the resulting system should be just like cash, but at the same time it should maybe have negative interest rates, which isn't much like cash. Or it should be cash, but where certain people on blacklists can't use it. Well, again, that's not much like cash. Now, I'm not trying to throw these requirements back at the users. That's not our role, because the motivations behind these requests are often understandable. So our goal here, and especially with this new office of the CTO and my new role, is partly to try and look at this and come up with new ways of solving some of these things. Now, I want to zoom in on just one requirement of these projects that I find quite interesting, which is the desire for electronic cash to not require electricity. This is something that we get asked sometimes. And let's talk about that. That's an interesting one. What happens in a world that got rid of all of its paper and metal money when the lights go out? Let's consider the worst case scenario of a full national blackout. How long do we need our eCache system to survive before it's okay for it to collapse along with the rest of civilization and we all end up mugging each other and killing each other, and the world becomes a zombie apocalypse. There's some time limit in which we have to survive this until it's okay for things to fall apart. And it's this, now, this may sound like a detail that's best left to later. I don't see many people think about this when designing eCache systems, but it's the sort of thing you actually need to think about from the start because it affects every other design decision. And even though R3 is not, we're not a cryptocurrency company, we're not in the business of making consumer money at the moment, this is the kind of area where I think we can contribute to the Korda community. So those of you who are interested in this kind of project can go ahead and do it. Now, it might appear at first that we can just kind of blow our way past this because we're developers, and developers write apps, and apps run on smartphones, and smartphones have batteries, so where's the problem? There are a couple of problems. One is that batteries are desynchronized, so at any given moment, there's lots of people about to run out of battery power, especially at night when it's often the case that power cuts happen. But actually, there's a bigger problem, which is they just won't last long enough, as we shall see in a second. Oh, and of course, merchants often use dedicated point-of-sale terminals, not phones. So a pure phone solution is never going to work. Now, if the national grid were to experience a nationwide blackout right now, this is something that is planned for. The UK has never had a nationwide blackout since the beginning of electricity in this country, but other countries have. Italy has had one in 2003, and just a few months later, the US Northeast grid collapsed. So this is something that is a real threat that is taken seriously and planned for. And if there was a blackout right now, and the entire grid tripped out, power engineers would begin a process called a black start. And in a black start, workers first establish nationwide contact via CB radios, because of course all the telephone system is down, and they begin a restart process where each power station is restarted, and the power from that station is used to restart the next station, because you can't actually boot up a power station without power from the grid. And so they do it one at a time until eventually they bring on all the power stations again. And if you look at their projections for what's involved, it's about 12 hours until they've got a skeleton network, which is only useful for bringing more power stations online. About 24 hours, they think, would have about 60% of supply reestablished. So we're looking at, I would guess, a minimum 72 hours after this process starts to get to full restoration. And this is a best-case scenario. If anything goes wrong during this process, the entire grid might trip out again, and we have to go back to the start and try again, because everything is very unstable during a black start. So my guess is that any eCache system we have needs to survive at least 72 hours with no power whatsoever. Otherwise, people have to resort to barter and IOUs on bits of paper and everything. People won't be able to buy things like water and stuff, and everything will just kind of collapse. So this immediately rules out smartphones as the only way to do eCache because they just won't last long enough. So what can we do? Well, it turns out that we already have a lot of the infrastructure rolled out to deal with this kind of thing. EMV smart cards are electronic, but they don't have batteries in them. They're energized by a radio field from the terminal. And prepaid cards exist. They're sort of cash-type wallet cards. And in EMV specifications, the Europay, MasterCard, Visa card specs support offline transactions because they go back, these technologies were designed in the 1990s before internet access was widespread. So we can have electronic wallets without batteries already. But this is basically a bank-oriented system. It doesn't have any of the features that you would get with tokens on a Corda ledger, and that's part of why we want to have eCache in the first place. So this can't be all we use by itself. So here's a possible plan. How about we do this? We start by combining SIM and EMV contactless chips. So every SIM card is also a digital cash wallet using this sort of old tech. We re-engineer the mobile system so that when the power goes out, mobile towers start doing emergency broadcasts with their remaining battery power, telling phones there's a power cut. And the phones forwards this to apps. Apps start up, and they start moving the tokens off the Corda ledger and into the SIM card EMV contactless card, right? So the money moves off the ledger and into this kind of emergency pouch that everyone has in their smartphone. And then the phone itself, they have these emergency modes, and the temporary chip balances can now be held against a terminal, point-of-sale terminal, even if the phone is powered off because it's run out of batteries. So this keeps working for as long as the terminals have batteries. Meanwhile, we give the terminals big batteries so that they can last a long time. And the terminals have an emergency mode in which, once this starts happening, people can use them to move money between each other. They're not just purchasing things from the merchant. They have a mode where you touch one phone, you push a button, you touch another phone, and you actually move tokens between them. So anyone who can get to a shop can trade with anyone else at any point. So people can give each other money to tide them over until the emergency is over. And the chips will be good enough to protect against double spending. When it's good enough for 72 hours or more. That's certainly the case. I mean, maybe we wouldn't want to rely on this all the time, but it's good enough as a backup system. And in this way, for the duration of a blackout, we can still trade, we can still do barter and buy things and give money to friends and family and so on. Even if there's no mobile infrastructure, if all of the towers are dead, there are no data centers anywhere, everything is dead except the batteries in the readers and the cards are still working, of course. Now, the cryptography of all this is a bit convoluted. We do have a lot of the details of this worked out. So I know there are people from central banks and governments here today. And if you're interested in this kind of project, come along and talk to us, and we'll happily tell you a bit more. All right, let's talk about things. Things. People love to do Internet of Things projects with Corda. We love this too. We've all got these things in common, and it's time to talk about it. So, for example, there's been a great project recently between Daimler Motors and Commerzbank in Germany. They've been putting Corda into trucks, and the goal here is that the trucks are able to pay for power. They're electric trucks. And then they can do payments from their vaults to buy electricity to recharge. There's lots of use cases like this out there. So for example, here's another use case. Right? Imagine we want cars to bid in real time for movement authority on a toll road. So to avoid it becoming like overcapacity and jamming up. So the car is constantly making payments to roadside beacons. Maybe it's taking part in for example, a Vickrey Clark Groves auction. And for those of you who know your auction theory, you'll recognize that as a type of auction that yields socially optimal results. And a VCG auction, people bid what it's really worth to them. But if your car starts losing the bids, then it should pull off at the next exit, right? So it's just sort of capacity management system. And there are lots of projects exploring use cases like this where we want devices to talk to each other and do economic activity. And a common starting point is to say, hey, why don't we put Corda into the car or the truck or the device? And some of you have tried this. You found it doesn't work very well. Corda's kind of fat, and it's getting fatter as we keep feeding it full of features. And we're pretty unapologetic about that because people want features, and this is software designed for data centers, actually. So this is maybe not the right way to do things. And actually, Corda is not unique in this regard, of course. Ethereum nodes and Bitcoin nodes and so on are also not designed to run in small devices. So what can we do? Well, it's probably a good idea to take a step back and ask what we're really trying to achieve here. If we could just magic away the size issues tomorrow, if we made a Corda node that was very small, would it make sense to use it? And I would argue that maybe it doesn't, actually. What we're actually wanting is a new kind of node which can extend or talk to data center nodes, but is not itself a part of the peer-to-peer network. And there's a reason for that, which is it probably doesn't make sense for devices to actually have vaults and make payments themselves. That would imply a lot of very weird things. For example, it would imply that if there was some sort of collision, imagine you have a flying quadricopter or something, and it's buying resources as it flies. If there was an accident, the money would be destroyed if there was a crash, which doesn't make much sense. Why would you lose the money if something crashed? Because it was inside it. Another is that you would have to regularly fill your car up with money, like as if you're filling it up with fuel, which is also kind of strange, and that would be inconvenient. While the money is held in a machine, it's not earning interest. It's not in a bank account. So people would find that a bit strange too. And in a related problem, cars, drones, whatever, don't have credit scores. So you wouldn't be able to buy fuel or whatever with money you haven't earned yet, which people love to do. And the end user would end up presumably filling up the car with money, but it should probably be the employer in many cases, or the owner of the vehicle. And finally, on the other side of this equation, if we think about this road toll thing, the money would end up like piling up physically at the side of the road and have to be collected, which would be really weird. Like just imagine going around collecting digital money, supposedly digital money from physical devices. That makes no sense at all either. So all this suggests that doing a cryptocurrency type thing and putting a wallet into a device is perhaps not the right way to think about this problem. So what is the right way to think about it? We can see there's a common pattern of requirements across all of these things. One is that physical proximity is important. Things in the real world, the Internet of Things, embedded computers, they matter to people because of the physical proximity between them, whether that's cable or being plugged into a charging point or radio. Security and authentication are key to all this. this is actually where we can add real value in this community and technology. Why is security on authentication key? Because otherwise you can get weird situations like your car might be driving down a totally free road and some clever hacker has set up a fake radio beacon that says they own the road and your car would just start paying it. That doesn't make any sense. You need to have some understanding that the other side of this equation is a real company that really is authorized in some way, so they need identity. Likewise, the beacon needs to verify who the car is, because otherwise someone might go out and impersonate your vehicle and run up a big bill on your behalf, even though you were never there, which is also a problem that shouldn't happen. So we need an integrated security and identity infrastructure for this IoT requirement pattern. And this is a common pattern. In fact, you've got two things in the physical world that want to connect. We'll call those two things device nodes. They're not full Corda nodes, right? They're not in the peer-to-peer network. They don't appear in the network map. And then we want some kind of connection as visualized by this awesome piece of stock video. I've never been able to just go and buy whatever stock video I want before. It's easy to go a bit nuts with it. And we want to establish sessions between Corda nodes in data centers, standard Corda nodes like today, and these flow sessions should be linked to a physical connection in the real world, such that app developers have access to all of the identities involved in this equation, not just the machine identities, but also the legal identities of the owners of both sides, and the owners and manufacturers. And we'll call this linked flow a ledger socket. I've written about this before. The device nodes here, they create ledger sockets, and a device node is really a small bit of code which is running on a device that has an identity, so a private key in some kind of smart card chip. It's a software library. We could write this in C or Rust or use Substrate VM to compile Java to native code or whatever. But the point is that it's a different code base, a little bit of a code that you add into your embedded IoT solution. Every machine has an identity in the Corda PKI identity system. So every machine has a name, which is the name of the manufacturer, followed by serial number, vehicle identifier number, whatever you want. And this works because the Corda PKI uses X509 name constraints rather than path length constraints like it does on the web. And we did that early on specifically to enable this kind of scenario later. So we've been thinking about this a long time, even though we don't currently use that capability. But it's there for when we need it. So at the factory manufacturers, they join the Corda network, they have a Corda node, and every time a new machine is manufactured, they issue a certificate, which they can do themselves. They don't need to contact the Corda Foundation or zone operator. Nothing appears in network map, so sales numbers are still private, and the cert is just blown to a bit of flash RAM on the disk or on the board or something like that. So armed with a certificate and some basic protocols we can design, just do some Diffie-Hellman handshakes and so on, we can put together this infrastructure such that every device ends up doing exactly what it should. The Corda nodes in bank data centers and in the financial world and hosted by tech companies or whatever, they are doing the financial side. They're making payments, they're doing credit, they're managing debt, they're doing auctions. And the devices in the machines are doing the things they're supposed to do, like indicating to the driver whether to turn on or off the road. All right, so that's IoT and retail eCash. Now, in the last part of my talk, I want to talk to you about things we are actually doing. I want to talk to you about our ongoing work with Intel on enclave technology. And those of you who have been in the community a while will know that we've been talking about this for a long time. This is a long-term endeavor for us. We've been laying out our plans. And when we started, we were totally alone. When we started, no one cared about SGX or enclaves except us, it seemed. But this has been changing over time. And nowadays, the other day I was reading that the Fabric guys are doing stuff with SGX, and the Enterprise Ethereum Alliance is doing stuff with enclaves now. And more of the blockchain community, the wider blockchain community, is coming in and saying, yeah, right, this is the way to go. We had fun with zero-knowledge proofs and things, but they're just too slow. They're too hard. And we've realized that to launch into production anytime soon, we need to use enclaves. So that's nice. And but we realized that to make enclaves work well for Corda developers would require a big effort. And we planned out a roadmap that looks like this. So we started with basic Java in enclave, hello world type stuff. We got that running pretty quick. Then we moved on to advanced Java. Lambdas, reflection, auto-generated, like this synthesized bytecode and all that kind of stuff. We started verifying Corda transactions inside enclaves because this is a part of how we bring privacy to the ledger with SGX. Then we added in our deterministic Java sandbox because that's important to minimize the number of transitions needed for app developers. And I should say now, if you've followed all the rules that were laid out in the beginning, your existing code should just work, in theory. If you did things that are not really allowed in your smart contract, they may work today because not all the rules are enforced, but you will have to then opt in for your app to be able to work in this new environment and benefit from the privacy, new privacy features. And then we started working now. We're deep into this last part here. Do I have a laser? Yes, I do. Signatures of validity, which are a way of avoiding ever sending transactions to peers. Instead, you send a statement generated by an enclave that says a transaction is valid. We have very detailed design on the way this is integrated. We have proof of concepts working. In fact, we brought up and we verified some transactions inside an enclave and generated this successfully a few days ago. Some of the design work has been shared with our trusted partners, and we'll be sharing it with the whole community soon after it's gone through that initial review. And if you come along to my demo session this afternoon, I'll be telling you more about this. But this is only for ledger privacy. This hides your transactions. This gives you better privacy on the ledger, but you can do much, much more with enclaves than that. What I want to talk to you about both in the remaining few minutes of this talk and at the session later is enclave-oriented computing. Right? I want to talk to you about all the things you can do with enclaves. We can do not just ledger privacy, but multi-party computation. We can reduce trust in cloud operators. We can lock down application stacks. We can do auditable software as a service. And that's like just, 10% of the ideas we've come up with for the ways to use this technology. But I want to start by focusing on multi-party compute, this first thing here, because we think that multi-party computation is going to be a fundamental capability that all blockchain systems will be expected to have in the coming years. Not just private data on ledger, but the ability to come together, contribute data into a shared calculation, and then get out your little bit of the answer in ways that are secure such that no one ever sees that pool of data. No one ever sees the whole set of data used for the calculation. So I'm telling you today, I want to announce to you Conclave, a new project that we're working on. In fact, I'm now working on this project full-time, which is taking the work we've done so far to run smart contracts inside SGX enclaves and generalizing it. So you can write non-deterministic, non-smart contract logic that runs in an enclave to do all kinds of computations between parties on a Corda network. It's integrated with Corda. It has a separate name because in future it may also be usable standalone if you want to provide your own identity infrastructure and so on. It's designed for Java and Kotlin developers, and of course Scala and anyone else generating bytecode is welcome too, and we'll extend to other languages in future. And the point of this is to enable all kinds of different computations, both over ledger data and just whatever other things you throw in as well. So as part of that work, I wanted to describe an initial use case. We wanted an initial use case that would help us learn what the APIs should look like, because if you try and build a platform without an application that you develop at the same time, it's very easy to make mistakes. It's very easy to put things in that don't matter or not put things in that do matter. So we wanted a real app to develop alongside this project. And so I went down to the offices of B3I, one of our great partners and app developers, because they happen to live down the road from where I do. So it was very easy for me to visit them. And we did some brainstorming, and we came up with an initial use case, which is we said, OK, let's do transaction pricing, which is multi-party compute over a set of Corda transactions to calculate an aggregated price that should be owed to the app developer for using a Corda app. Because all Corda app developers face this problem of how do you price and how do you bill for the use of the Corda app. And if you don't have this kind of technology, then you can very easily end up with weird pricing traps. Like you can set like a flat per transaction price, and then users are tempted to like cram 1 million states into one transaction to play games, or people won't use features of your app because the feature needs a ledger transaction, but it ends up costing too much for what it's worth. You want most kinds of transactions will be administrative in most Corda apps, and you want them to be free. But then the app developer needs a way to make a living too. So we said, OK, this is a good start because we're actually taking ledger data and doing a multi-party computation over it. And we started developing this. I will demo it to you this afternoon if you come to the demo session. And of course, you will also have ideas for what to do with this. You will also have all kinds of bits of business logic, all kinds of calculations where you want to eliminate a trusted third party and have computation over private data. And that's why today we want you to sign up for the Conclave beta program, which will begin as soon as we've finished polishing off the current API. If you go to this URL, you can sign up for a mailing list, and we'll get in touch with you as we start inviting people into this beta program. We plan to do exactly what we did with Corda, a series of milestone releases with a gradually expanding community as we get more feedback, until eventually it becomes a released product and a part of Corda itself. That's what I've got time for you today. So thank you very much for listening. If any of the stuff we've discussed today is interesting to you, you can come and talk to us about it on the Corda Dev mailing list, or you can get in touch with professional services, or just come find us here at this conference. Thank you very much, and I hope to talk to you later.